Thank you for holding this hearing on such an important and urgent issue, and I'll reiterate Dr. Earle's comment. We have a serious problem. I'm a scientist at the National Center for Atmospheric Research, and I've specialized on coral reefs for about 20 years. I thank you for this opportunity to discuss two serious consequences of climate change for coral reefs: ocean warming and ocean acidification. Oops. Since the 1950s, the tropical oceans have warmed on average by more than 0.5 degrees Fahrenheit. And this warming has caused a phenomenon called coral bleaching. Bleaching happens when a coral expels a colorful algae that lives within its tissue and provides that coral with most of its energy. Bleaching is often fatal. Coral bleaching has already destroyed about 10% of reefs worldwide and has weakened many more. The projections of bleaching patterns indicate that if ocean warming continues along its current path, we will lose this ecosystem. We hope that corals can adapt to the warming, but there's really very little evidence that they can do so. The other problem I want to raise is something known as the other carbon dioxide problem. This is ocean acidification. The concept of ocean acidification can be explained with a bottle of carbonated water. So that water was carbonated simply by adding CO2 or carbon dioxide to it. And carbonated water is more acidic than just regular tap water, and anybody can test this with litmus or pH paper. The oceans have already absorbed about 1/3 of the carbon dioxide released into the atmosphere by man's activities, and this really is a natural gift because it lessens the impact of climate change, but it's changing ocean chemistry. Although we can't feel the change, we can measure it, and measurements are confirming that ocean acidification is indeed happening. So there are two main ways that ocean acidification affect marine organisms. First, it can stress the organisms physiologically, such as increasing its respiration rate, lower reproduction, and lower survival. And second, what we know the most about too is that acidification impacts the ability of marine organisms to secrete their skeletons or their shells. This includes many important groups of marine organisms, from microscopic algae at the base of the food chain to familiar organisms like clams, starfish, and corals. Corals are the best studied of these, and there's strong evidence that their calcification rates will decline by 10 to 50% within the next 40 to 50 years. They simply won't grow as fast, or they'll grow more fragilely. And you can think of it as osteoporosis. This slide shows a dramatic example of a coral cultured in normal versus acidified seawater. Ocean acidification not only slows skeletal formation, but at some point it actually dissolves it. So what does this mean for the coral? Well, organisms that produce shells do so for a reason, for protection, for example. Even if this naked coral in this slide could somehow survive in the real world, it would be living as an anemone, not as a coral, and it wouldn't be producing coral reefs. In fact, reefs themselves exist because corals and other organisms build the reef faster than it is eroded. Ocean acidification attacks the reef structure itself by increasing the rate at which it dissolves. And if reefs erode away, we will lose many of the valuable services that they provide, and that includes high biodiversity, fisheries, and shoreline protection. So what can be done about ocean acidification and warming? Obviously, reducing greenhouse gas emissions tackles the root cause of both, and we need to reduce those emissions aggressively. Given that coral bleaching is already so widespread, we may already be above the threshold for that ecosystem. For acidification, certainly we need to find a way to keep carbon dioxide levels below 500 parts per million, because above that level, some reefs will start to erode away. It's worth noting here that geoengineering solutions to reduce warming, such as putting dust into the atmosphere or sunshades in space, do not solve the problem of ocean acidification, because those solutions don't reduce carbon dioxide concentrations in the atmosphere. I want to also stress that ocean acidification affects not just coral reefs, but it affects all marine ecosystems. And I really feel that this may be the greatest environmental threat that we face this century. It's a new issue, and we have our hands full just trying to understand the scope of the problem. We need to know how much carbon dioxide is too much carbon dioxide, but we also need to know what we can do to help marine ecosystems make it through this difficult time. So I urge you first to take on the task of reducing greenhouse gas emissions, and second to pass the 4M Act, which is an act to increase research on ocean acidification. And I just want to sign off with a comment that 25 years ago, we thought that global warming was going to be good for reefs because they like warm water. They would expand. Well, now we know about coral bleaching. We know about ocean acidification. Climate change is not good for coral reefs. And what's at stake if we lose them is the most biodiverse ecosystem of the ocean. It's one that supports major fisheries and economies of the U.S. states and territories. It protects many shorelines, and of course, this is a masterpiece among God's creations. Thank you very much, and I'm happy to answer questions.